Good afternoon, everyone. First of all, I would like to introduce myself. My name is Sokanya, and I am a CEO of XBIM Engineering Solutions. It's my pleasure to be here today for the presentation about the application of BIM technology for building construction in Cambodia. Here is the content for my presentation today. So first, I will overview the XBIM company and talk about some issues in the building construction in Cambodia. Also, the adaptation of BIM in design collaboration, AI mobile application, and the conclusion. Here is the overview of XBIM. XBIM Engineering Solution is a design and consultancy company which provides service for the whole life cycle of the building and infrastructure project. It makes us unique in the construction industry in Cambodia because of the application of the BIM technology, which provides the whole picture of the project from technical and financial aspect in the design stage and the construction stage as well. The name of XBIM was derived from the letter S, which has unknown solution, refer to unknown solution that need to be solved, and BIM is the state of art, the technologies being used in the construction industry nowadays. Our company was founded in 2019 by a group of 3 Cambodian engineers graduated from one university in South Korea. And we also cooperate with the basic source company, which is one of the Korean leading company in the building and infrastructure with BIM technology. Let's move to the issue in the building construction in Cambodia. It has some problem in the AEC industry. So first is the cost overrun and some design delay and low productivity, also the safety issue, and some waste of material in the construction site, and also poor coordination. This problem makes the construction site face many cost and time consuming. Also, the customer interface, external factor, sharpen the coordination and storage management as well. So for this part, we divide into time factor and cost factor. So for time factor, the project clarity and the communication, mostly we do the communication mainly by mail, telephone or business meeting. It's really time-consuming job in this discussion, and the design, data translation, data redefine, and too many design change, too many redesign in the construction stage. It's really time-consuming that we have made previously. And also the cost factor due to the preliminary engineering and also the unexpected incision. The material waste due to poor site supervision, poor planning, improper storage, and also waste of material left at site. Also waste, mostly we have 1 to 10% at this real construction site. So because of this problem in the construction industry, we start to thinking about adapt the BIM technology in the design and construction stage. So this one we will talk about the adaptation of BIM in design and collaboration. Here's the BIM implementation project that we do in Cambodia. So this project is the condominium building, which is located in Phnom Penh, Cambodia. It has gross area around 9,000 square meters with 11 stories. And the application of this project is the structural, architectural, and MEP design, also the BIM modeling, and construction detail drawing, class detection with the coordination, and the 4D and 5D simulation. The expected result from this application is error checking and monitoring. We hope that it increases the design's quality by reducing design error. And here's the BIM implementation process. So we have the architectural model, and structural model, and MEP model. And then this model we will integrate into BIM platform. And this BIM platform has the design review, class detection, and then design analysis and design optimization. The construction simulation, constructability, it can be construct or not. Schedule optimization, also the animation of the construction. And for the material management, we can get the advantage for the quantity takeoff, material plan, and also finalize material control, stock control at the real side. And design collaboration, for the collaboration stage, so it has many parties that we do together, like architectural, structural, and MEP. So we use this server, like central server, and then we have the local server. We combine it to the central server. And the other way that we do for the construction collaboration step is the collaboration with the cloud system, with BIM 360, and then the design stage and another document in the construction stage is put into this cloud system. We work together in this cloud system. And for the design and visualization, this one we show about the architectural design. We have the 3D modeling, and in this 3D modeling, BIM 3D modeling, we can get the elevation view and even the layout to the construction plan for the contractor. And we also get the 3D rendering. In this 3D rendering, we do the process by modeling in BIM modeling in Revit, and then we export, we integrate into the landscape, and then do the rendering in the landscape. And not only the exterior rendering, but also the interior rendering for the advertisement. So we do the interior rendering for each unit of that condominium for the advertisement. And this video will show the real-time rendering. This part is the Revit part, and then this one is the landscape part. So this one is BIM model, and then we link into the real-time rendering program. So when we have changed some model in this model, and then the rendering will be changed automatically. It makes us much more easy for the rendering. And this one is the structural model. We have the 3D structural model, and then we check the analytical structure of that software, and we link from that structural model in structural BIM model into structural analysis program. We integrate it, so we can get the analytical program for structural analysis easily. After we design, so we have the construction drawing. So this one is layout plan, elevation plan, and also the detail section, 3D detail section of that element in each element, like beam, parquet, column, stair, or something else. And this one is walkthrough for structural part. So not only the architectural part, but structural also can do the walkthrough video. So we can see the whole of the building. So also the reinforcement. We also can see the reinforcement, how the reinforcement look like, how it's going to be. So it's really easy for the contractor and also for the owner. It's really interesting. Another part is MEP design. So we have the 3D modeling for that MEP, and it has in each component of that MEP equipment have their own information. And after modeling, we have the quality checking, right? So we need to check whether our model is good enough or not. So first we do the self-check, and then coordination check and version check. For the self-check, we check the quality of model itself, and then do the class between different models and compare between the old and new version model. And here is the diagram for that quality checking. So as I said, this one is we have the architectural model. So we have architectural BIM quality checking and structural BIM quality checking, MEP BIM quality checking. It is self-check quality model, right? And then after we check it, and then we integrate model, and then we do the coordination and class check. After do the class check, we can get the report. If it is okay, so we can do the final report, but if it's not okay, so we need to discuss about that problem and then make the modification model. And here is the sample of our architectural BIM quality check. Here is drilling and column. So in this part, it has some detection. So after we check interference of that, we can get report of that. So we can know that our model has some problem, so we need to rechange before submit to the integrated platform. And for the structural model as well, so it has one problem for that. And for the MEP model, it shows that no interference detected. So it means that our model, MEP model itself, the quality of model is good enough for the integrated platform. And after self-check model, we do the class detection checks between the architectural model and MEP model. And this one reflects the architectural model and MEP model, and then we type of class detection and the tolerance of that. And then we run the test. And then after we get the result, we see that it has 10 class, and we can show this report when we click it, and it shows where it's located and how it looks like. And we also extract the report. This one is text report, and the figure of that in JPEG or the PNG file, so we can know how it looks like and where is located for that item with this report. So after we do the quality checking of the model, we also check the quantity takeout by architectural schedule. So by this one is architectural model, and then we can get the schedule from the wall material schedule, door window schedule, and even the painting schedule as well. Structure as well, we can get the rebar schedule, column, stair, slab, and beam schedule. And this one is MEP schedule. And after the schedule, we will do the 4D simulation. So we have the construction project schedule that we have done in the Microsoft project. Then we have this BIM modeling, so we can combine it and call it 4D simulation, 4D BIM modeling. So we can have the animation of the we can have the animation of the building with this times and day. It has day and weeks from the start to the end of the progress of the project. And this one is the item element that is constructed, and this one is the construction percentage of that. Yeah, another after the STEAM modeling, we also have the AR mobile application. Yeah, it's really new for us, but we are happy to do that. So we start the AR mobile application. We do the project 3D model, BIM model, and then we export to FBA file. And from FBA file, we import into Unity 3D for create AR application. And in Unity 3D with the Fourier add-in, so we can get the AR application used by smartphones. And this video will show the AR mobile application creation with the macOS. So this one is the layout, and then we open the application and show the architectural model, structural MEP model, and even though the animation model. And this one is the animation of the construction project with in that AR mobile application, which is based on this layout that we can call it AR macOS. Yeah, we try to do that, and it's really amazing, and it's our first time, and we will continue to develop more for the real construction side. And not only the building, but also the grid and the infrastructure. We can do in the AR mobile application by loading the model into that AR application, and we can show in the real environment not only the layout plan anymore, but in the real model, and then we can rotate or scale the model easily. So it's really useful for owner to visualize how their model look like. Yeah, conclusion. In conclusion, I can say that BIM can have construction industry in Cambodia like to improve the visualization of the construction projects and improve the productivity due to the easy retrieval of information, and it increased the coordination of the construction document and also increase the speed of delivering due to the collaboration process. We don't need to wait time for the mail and telephone or business meeting anymore, but we work in the cloud system, also the central server system. And we have a better communication with clients because we provide the 3D PDF file format that is easy for client to rotate the model and see how it looks like. Also, they can know easily about the progress of the construction site by the point simulation, and also AR application, because AR mobile application, they just scan our model and then they can see the AR model in the real construction world environment. So I think it's really helpful for us. Okay, that's all for my presentation today, and I would like to say thank you for your listening. Okay, thank you.